Okay, so we're going to continue. The answers for 18.3 reteaching, number 1, 2, and 3 are all based on this triangle that is given. This is actually a 45, 45, 90 because we can tell that one of the angle is measured 45. So let's answer the question. Number 1, it says, what is the length of BC? So we're looking for BC, and we know that this is a 45, 45, 90, again, right triangle. So BC is actually going to be, because it's isosceles, it's the same length as AB. So the length of BC is 6 units. And number 2, the length of AC. In a 45, 45, 90, there are 2 different lengths. The one is the length, which is 6, and the hypotenuse is given by the leg times radical 2. So therefore, the length of AC, which is the hypotenuse, should be 6 radical 2. And finally, the measure of angle A, we already identified it earlier, which is 45 degrees, because that would be that would make this a 45, 45, 90. 90 minus 45 is 45. And that's number 1, 2, and 3. So moving on to the bottom, we have a 30, 60, 90 triangle, right triangle. And the first question is asking, what is RT? We know that this is a 30 degree, and that is a 60. So we know that the leg that is opposite of 30 would be the shortest. So it goes 30, 60, and 90. And so the leg that is above, opposite of the 30 degree is given, which is 4. We know that the relationship from the short leg to the 60 degree is going to be the short leg times radical 3. And so that would, we would know that in this case, 4 radical 3 is this, which is opposite of the 60 degree. So that would be 4 radical 3. And so the next thing we know is that the relationship between the short leg and the hypotenuse is that hypotenuse is 2 times as long as the short leg. So that would be 4 times 2, which is 8. So now we have identified all 3 sides of the triangle. Let's go ahead and answer some of the questions. Number 4 is asking for RT, which we already know. We found that it's a hypotenuse, which is twice, so it's 8. Number 5, RS, which we also found, it's the longer leg, so it's 4 times the square root of 3 times as much as the short leg. Number 6 is asking for the sine of 30 degree, which is this angle right here. So we know that given the sine is the ratio opposite over hypotenuse, that would be opposite of 30. That's 4 divided by hypotenuse, which is 8. And we can just easily reduce that to 1/2. Number 7 is asking for the cosine of 30. And we know that cosine is adjacent of hypotenuse, which means adjacent to angle 30. That's 4 radical 3 divided by the hypotenuse, which is 8. And we can reduce that to 2. So the reduced fraction would be radical 3 over 2. Number 8, we're looking for the sine of 60. Again, it is the same ratio for sine, which is opposite of hypotenuse, but we are talking about a different angle here. So angle 6, opposite of that is 4 radical 3 over hypotenuse, which is 8. And again, we can reduce the fraction to radical 3 over 2. And next, we're looking for the cosine of 60 degree, which means, again, adjacent over hypotenuse. And that will give us adjacent to 60, which is 4 over hypotenuse, which is 8. And that's 1/2. And looking at these numbers here, just recall that in class, we did say that the sine of 30 degrees is equal to the cosine of the complement. So that would mean this 1/2, and here the cosine of 60 is also 1/2. That is not a coincidence. So it actually works out. And the same thing for the cosine of 30, which is radical 3 over 2, will equal to the sine of the complement, which is 60 degrees. So those values are equal as well. The last 2 questions call for the tangent of the 30 and 60. So the tangent of 30 degrees is opposite over adjacent. So that would be opposite of 30, that's 4, over adjacent, that's 4 radical 3. And we can reduce the 4's, and we have 1 over radical 3. And remember that in math, we cannot leave a radical in the bottom of a fraction. So we're going to have to rationalize by multiplying by the square root of 3 on top and bottom. That would be the same fraction. So we're multiplying by 1, which does not change the problem. So on top, I have radical 3 over on the bottom, 2 radicals 3's make 1, 3. So that would be the value for the ratio for the tangent of 30. And the last question is tangent of 60. And using the same ratio, tangent is opposite over adjacent. Opposite of 60 is actually 4 radical 3 over the adjacent, which is 4. Again, the 4's get canceled out, and it is radical 3. And since we don't have any radical underneath the fraction, we are okay with radical 3 as an answer. So that's the final answer. And that is all for reteaching 18.3. Now moving on to reteaching 18.4, which deals with solving for a triangle. So the first 3 questions deal with this triangle right here. It says solve the triangle by finding the missing information and round to the nearest tenth if necessary. So the first question is asking for us to find angle U. And angle U is this angle right here. That's the acute angle. And the way that the problem is given, we are given the opposite side and the adjacent side to angle U. So that would involve the ratio tangent. So we can just set up the problem to say that tangent of U is equal to opposite over adjacent, which is 7 over 24. And again, using the inverse to cancel out the tangent, we have angle U is equal to the inverse tangent of 7 over 24. And if we simplify that in the calculator, we can round the answer off to 1 decimal, which is what they want. And you get about 16.3 degrees. And that is what this angle is, angle U, 16.3. And next question is asking you to find angle W. There are 2 ways to do this. One is that realizing this is a right triangle, therefore the acute angles are going to add up to 90. We can take 90 minus the angle that we found, 16.3, and we will get 73.7 degrees, and that is what this angle here, W, is has to measure. Another way is to also set up a tangent ratio to solve for the unknown signs, just like we did earlier. So we can say that angle W is the inverse tangent of opposite, which is 24 over 7. And if you solve that, you will also get the same angle of 73.7 degrees. Finally, we're asked to find the leg of UW, and that is the hypotenuse in this triangle. And so our good old friend, the Pythagorean theorem, will come in handy. So we have one side squared, 7 squared plus 24 squared is equal to UW squared. And working out the math, we have 49 plus 576 is equal to UW squared. Adding the 2 together, we have 625. And finally, taking the square root of both sides, we will have UW is equal to 25. So the length of UW is actually 25 units. And moving on to the last question is finding the area of a triangle. And we are given, looking at the example on top, the formula is to make use of the sine ratio. So we're given 2 sides and the angle in between. So to find the area of the triangle, it will be 1/2 the 2 sides that are surrounding the angle would be 22 and then 17. Then we will take the sine of the in-between angle, which is 18 degrees. And we have simplifying here. And if we simplify 11 times 17 times